This lesson is on chapter 6.3, showing that quadrilaterals are parallelograms. A parallelogram is when both pairs of opposite sides are parallel. You can find a table with the same information on page 219. In theorem 6.6, both pairs of opposite sides are congruent. You can see that in the picture. This tick mark is congruent to this tick mark, and the upper sides congruent tick marks are congruent to the lower sides tick marks. Okay, since when you know it's a parallelogram, you'll know that both pairs of opposite angles are congruent. Here's a picture to represent that, and that is theorem 6.7. When you have a parallelogram, theorem 6.8 says one angle is supplementary to both. Again, that both is important. It's consecutive angles. So if you look at the picture of this parallelogram, if you have the y degree angle, it will be supplementary to this x degree, and it will be supplementary to this x degree as well. Okay, the final thing that you can show when you have a parallelogram is that the diagonals that bisect each other are going to be, you can show that diagonals bisect each other by showing the congruent tick marks. You draw in the diagonals on a parallelogram. This segment will be congruent to this segment, hence the congruent tick marks, and this segment will be congruent to this segment, hence the congruent tick marks, because each of the diagonals bisect each other into two congruent parts. Going back to theorem 6.8, just reiterating the meaning of supplementary. If you take x angle and y angle, those degree measurements, they will equal 180 degrees. If you take this x degree and this y degree, it will also equal 180 degrees. Okay, we're going to do the page 317 checkpoint exercises for chapter 6.3 to show that quadrilaterals are parallelograms. In number 1, we have the parallelogram A, B, C, and D, and the one pair of opposite sides, A and D and C and B, are 4. The other pair of opposite sides, C, D, and AB, are 5. So yes, it is a parallelogram because both pairs of opposite sides are congruent, which is going to be theorem 6.6. In checkpoint activity number 2, in this figure, this quadrilateral JKLM, when we look at it, it is not going to be a parallelogram. So no, it is not a parallelogram because both pairs of opposite angles are not congruent. So L is not congruent to J, and K is not congruent to M. On page 319, the checkpoint activities 4 through 7 ask the question, tell whether a quadrilateral is a parallelogram and explain your reasoning. In number 3, we have the parallelogram EFGH, and the angles are written in the picture. There are 2 explanations as to why this is not a parallelogram. The first is it's not a parallelogram because opposite angles are not congruent. 80 degrees is not congruent to 130 degrees. That's theorem 6.7. And the second explanation is no, the consecutive angles are not supplementary, which is theorem 6.8. 130 and 60 is 180. However, 60 and 80 is only 140. So it's not, angle F, 60 degrees, is not supplementary to both E and G. Okay, in number 5, for parallelogram KLMN, you're given the angles 104 degrees, 76 degrees, and 104 degrees. There's going to be 2 explanations as to why this is a parallelogram. It's helpful to know that 360 degrees is the measurement of all quadrilaterals. So if I add 104 and 104, I get 208. Plus the 76 gives me 284. Subtract it from 360 degrees, and I get 276 degrees. So both pairs of opposite angles are congruent. It's one explanation. And the second explanation is that the 2 consecutive angles are supplementary. So for instance, 104 is supplementary to 76. And 76 is supplementary to this 104. So 76 is supplementary to both. Okay, number 6, parallelogram PQRS. This is a parallelogram because the diagonals bisect one another, which is going to be theorem 6.9. Number 7 is the quadrilateral TUVW, and the diagonals are drawn in. It looks a little bit misleading because the numbers are the same, but you can see that diagonal VT does not bisect UX and XW, the numbers are different, nor does UW, that segment, that diagonal, bisect VT because TX is 4 and XV is 5. So it is not a parallelogram because the diagonals do not bisect each other, and that's theorem 6.9. Your assignment for chapter 6.3 showing that quadrilaterals are parallelograms is pages 320 to 321, problems 8 through 19. Please do your problems on the right-hand side of your paper.